In this video, we are going to look at some examples of indices. We are asked to simplify the following indices. Number 1, we have 10 raised to the power 5 times 10 raised to the power 4. Let me write it here. 10 raised to the power 5 times 10 raised to the power 4. Firstly, we have to understand what an indices is. Let's see, we have 10 raised to the power 5. 10 is called the base of the indices, while 5 is called the power or the exponent. Now, 10 raised to the power 5 is an indices. Also, 10 raised to the power 4 is an indices. In order to solve this easily, we are going to apply some law of indices. We are going to apply some laws of indices. Now, whenever you have two indices that has the same base, as you can see, the base of the first indices here is 10, and the base of the second indices is what? It is also 10. Once the base are the same and we are asked to multiply, we are going to add the power. Again, whenever you want to multiply two indices with the same base, we are going to add the power. So we are going to have 10 raised to the power 5 plus 4. So the powers are 5 and 4 respectively. And that's going to give us 10 raised to the power 5 plus 4 is 9. So the final answer is going to be 10 raised to the power 9. In example 2, we have 5y times 4y raised to the power 4. 5y times 4y raised to the power 4. 5 and 4 are two numbers, ordinary numbers, we call it constant. So we can rearrange this and have 5 times 4 multiplied by this y times this y raised to the power 4. So you rearrange this, you write this in this way, in this form. 5 times 4, that is 20. Now, there is one hidden one here. There is one that is hidden here. So y raised to the power 1 is equal to y. Now, we are going to apply the law of indices that whenever we have the same base and we ask to multiply the two indices, we are going to add their powers. So the base of these two indices are y respectively. So now we are going to say 20 times y raised to the power 1 plus 4. So that is going to be 20 times y raised to the power 5, which is also equal to 20y raised to the power 5. In example 3, we have m raised to the power 8 divided by m raised to the power 5. Now this time around, we are going to divide indices. So whenever you ask to divide indices, we are going to apply another law. And this time, so we are going to have m raised to the power 8. So we are going to subtract the powers. So instead of adding the powers. So in the previous example, example 1 and example 2, we added the powers because we are multiplying indices. But this time around, we are dividing indices. We are going to subtract the powers. So we are going to have 8 minus 5. So the final answer is going to be 8 minus 5, that's going to be 3. So it's going to be m raised to the power 3. Example 4, we have 24 x raised to the power 6 divided by 8 x raised to the power 4. So 8 in 8, 1, 8 in 24, 3. So we have 3x raised to the power 6 over x raised to the power 4. So this is an indices, also this. So you can write this expression as 3x raised to the power 6 divided by x raised to the power 4, because this over means divided by. So now we have 3. So whenever you are dividing two indices, so you subtract their powers. So we are going to have 6 minus 4. So the final answer is going to be 3x raised to power 2, 3x squared. In number 5, we have 9 times 10 raised to power 9 over 3 times 10 raised to power 3. So 3 in 3, 1, 3 in 9, that is 3. So we use this. Now we have 3 times 10 raised to power 9 over 1 times 10 raised to power 3. Now we have two indices here, one at the numerator and the other one in the denominator. So the base are the same. We have 10 as the base of the two indices. So, and as you can see, over means we are going to divide. It means division. So we can write this as 3 times 10 raised to power 9 divided by 1 times 10 raised to power 3 is the same thing as 10 raised to power 3. So everything we have here is 10 raised to power 3. So this gives us 3 times 10 raised to power 9 minus 3. We are going to subtract the power of the indices. Now we have 3 times 10 raised to power 9 minus 3 is 6. So this gives us the final answer. In number 6, we have 2 raised to power 0. Any number raised to power 0 is equal to 1, because 2 raised to power 0 now, 2 raised to power 0 could be written as 1, 2 raised to power 1 minus 1. 1 minus 1 is equal to 0. And if we transform this, that's going to be 2 raised to power 1 divided by 2 raised to power 1. And that is 2 divided by 2, and that is 1. We try it for another number, be it 5 raised to power 0, 100 raised to power 0, it will always be 1. So any number raised to power 0 equals 1. Number 7, 4 raised to power minus 3. In this example, we have negative power, which is minus 3. So we are going to rewrite this. We are going to transform this. This minus, this negative means that it is 1 over 4, the base, and the power, raised to power 3. Again, let's say we have 5 raised to power minus 5. So this is going to be written as 1 over 5 raised to power 5. Whenever you have a negative power, it is going to be 1 over the positive indices. Number 8, we have 1 over 4 everything raised to power minus 2. Before we continue, from the previous example we had 4 raised to power minus 3, and we said the final answer is 1 over 4 raised to power 3. Actually, 4 could be written as 4 over 1. Now you see 4 over 1 raised to power 3. It's as if we just transform this. Also, we take the numerator down and the denominator up, and it gives us 1 over 4 raised to power 3, which is the same as 1 over 4 raised to power 3 this way. So the same thing here, we are just going to bring the denominator up and bring the numerator down, and that's going to be 4 over 1, or let's say 4 over 1 raised to power minus 2. Now that we have interchanged this, it's not going to be minus 2, it's going to be positive 2, which is the same thing as 4 raised to power 2, and this gives us, that's going to be 16. And if we want to write this fully to us, so it's going to be 1 over 4 raised to power 3, that is 64. Now question number 9, we have 5x squared times 4 x raised to the power 0 times 2x raised to the power minus 6. Now you can rearrange this and write 5 times 4 times 2. So we firstly write out the constant, the numbers, then multiply by x raised to the power 2, multiply by x raised to the power 0, multiply by x raised to the power minus 6. 5 times 4, 20 times 2, that is going to be 40. Now times, so we are going to multiply these three indices. They have the same base, which is x. Then we are going to do all to their power. So we are going to add them. 2 plus 0 plus minus 6. So that is going to be 40x. 2 plus 0, 2. Plus minus, that is going to be minus 6. And this is going to be 40x raised to power 2 minus 6. 2 is less than 6. 6 is bigger. So the answer is going to be negative 4. So we got 40x raised to power minus 4. So in order to write this, we can have we have 40 times x raised to power minus 4 is the same thing as 1 over x raised to power 4. So the answer is 40 over x raised to power 4. In the last example, example 10, we have 15 times 10 raised to power 4 divided by 3 times 10 raised to power minus 2. If you look at this expression, we have something inside the bracket. We have division here. So we can write this as 15 times 10 raised to power 4 divided by 3 times 10 raised to power minus 2. 3 here 1, 3 here 5. Now we have 5 times 10 raised to power 4 over 1 times 10 raised to power minus 2. 10 raised to power 4 and 10 raised to power minus 2 are two indices with the same base. So we can write this as 5 times 10 raised to power 4. This over means divided by 1 times 10 raised to power minus 2, that's going to be 10 raised to power minus 2. So these two indices with the same base, when we want to divide them, what do? We are going to subtract their powers. So we have 5 times 10 raised to power 4 minus 2. And this gives us 5 times 10 raised to power minus, that's going to be plus 2. And this is equal to 5 times 10 raised to power 4 plus 2, 6.